Let's take a look at problem number 11. This is going to use the zero factor property. So let me refresh your memory on that. So zero factor property. Different books call this by different names. Some say zero product principles, a lot of different names. Basically says if you got something times something else equal to zero. If P times Q is equal to zero, P and Q can be anything. Then you can set P is equal to 0, and you can set Q is equal to 0. So let's see, problem number 11. Negative 6x squared minus 7x plus 3. Now always, our first method of factoring is the GCF. Now these don't have anything in common, but I notice my first term is negative. And when working with GCF, if your first term is negative, you always want to factor out a negative number. So factor out a negative 1. And that's going to flip the signs. So it becomes a positive 6x squared, positive 7x, and a negative 3. Now, here we have x squared, x, no x, and there's a number over the x squared. This is the key number. With a key number, we take the number at the beginning times the number at the end, ignoring signs. So we're going to take 6 times 3. Notice I'm ignoring the negative on the 3. 6 times 3 is 18. And then I'm going to come up with 3 columns. A P column, an S column, and a D column. The P stands for products, so it stands for all the we put all the products of 18. So 1 times 18, 2 times 9, 3 times 6. In a sum column, we add those two numbers together. 1 plus 18 is 19, S for sum. 2 plus 9 is 11, and 3 plus 6 is 9. In the difference column, we'll subtract a smaller from a larger. 18 minus 1 is 17, 9 minus 2 is 7, 6 minus 3 is 3. Now the number we're looking for is a number in our middle term, which is a 7, which is right here. So we use 2 and 9. Negative 1 carries down, it doesn't change. And we're going to rewrite our middle term using those two numbers. Now our larger number in the P column, which is 9, is going to be the same sign as the middle term. It always will be. So the middle term is positive, so the 9 will be positive. So we've got a plus 9x. If the number you circle is in the S column, then it'll be same signs, both positive, both negative. If the number you circle is in the difference column, one will be positive, one will be negative. Number we circled is in the difference column. We said 9 was positive, so the 2 has to be negative. And then we'll factor by grouping. Negative 1 still carries down. Looking at my first group, they have a 3x in common. And that gives us 2x plus 3. Second group doesn't have anything in common, but the first term is negative. So remember, we want to factor out a negative. And that leaves us 2x plus 3. Now they both have a 2x plus 3, so I can factor that out. Negative 1 still out in front. And remember, we cross this out to see what goes in our second set of parentheses. And what isn't crossed out goes in there. So we have 3x minus 1. So we got 0 on one side, we factored the other side. The reason why I like this name so well is it tells you exactly what to do. 0 tells you get 0 on one side. And factor says factor the other side. Well, now it says I can set each one of these equal to 0. If I set the negative 1 equal to 0, we're solving for x. There's no x to solve for in S, so that drops away. You never set numbers equal to 0. They just end up dropping away with the zero factor property. So we'll set 2x plus 3 equals 0, and we'll set 3x minus 1 equals 0. Now these are linear equations, so I'll move the 3 over to the right side. We get 2x equals negative 3. Same thing here. 3x is equal to 1. You take anything across the equals, the sign changes. Divide both sides by the number in front of your x. So divide both sides by 2 on this side. And we get x equals negative 3 halves. And on this one, divide both sides by 3. And I get x equals 1/3. So let's see which one's our answer. Negative 3 halves and a positive 1/3. It's like D as in David. That's our answer.